The James Webb Space Telescope has used infrared light to pierce the high-level orange haze that shrouds Saturn's largest moon, Titan. Using several infrared filters, the false color image captures clouds and several surface features, including Kraken Mare, a methane sea, Bellet, a region of dark-colored sand dunes, and Adiri, a bright albedo feature. The James Webb Telescope provides some of the best resolution of Titan's surface, since the Cassini-Huygens mission ended in 2017. Cassini created a global map of Titan's surface using infrared imaging, from dozens of flybys over its 13-year mission. Even with Webb's enormous mirror, its resolution cannot match what was lost with the demise of Cassini. A new mission to Saturn is needed to continue the exploration of Titan. Dragonfly, a nuclear-powered copter, will fly across the surface of Titan. Titan's dense atmosphere and low gravity make flying an ideal way to travel between diverse areas on the large moon. Developed by Johns Hopkins Applied Physics Laboratory, as part of NASA's New Frontiers program, Dragonfly will analyze the composition of the surface and atmosphere, while looking for chemicals related to both water and hydrocarbon-based life. Launched in 2027, it will take Dragonfly 7 years to travel from Earth to Saturn, including multiple flybys of Venus and Earth to provide gravity assists. However, before Dragonfly can start its scientific mission, it will have to survive a harrowing descent to the surface of Titan. First, the probe's cruise stage will be jettisoned, and protected by its heat shield, Dragonfly will plunge into Titan's thick atmosphere. A drogue chute will slow the spacecraft. At approximately 4 kilometers above the surface, the main parachute will be deployed. Next, the heat shield will drop away from the back shell, exposing the lander. Dragonfly will deploy its landing skids and power up its instruments. At 1.2 kilometers above the surface, Dragonfly will be released from the back shell. The craft will fly over the surface of Titan, performing landing site reconnaissance. Dragonfly will select a suitable site and land autonomously. Titan's haze and distance from the Sun precludes use of solar power. Instead, a nuclear multi-mission radioisotope thermoelectric generator, similar to the ones used by the Curiosity and Perseverance rovers on Mars, will provide power in conjunction with lithium batteries. The nuclear generator will slowly charge batteries during Titan's 8-day-long nights, while the batteries will power the science instruments, communication equipment, and flying, during the equally long days. Dragonfly's scientific payload includes several spectrometers to measure the composition of the material under the lander and samples collected by drills and hoses on the landing skids. The probe will also carry multiple cameras, meteorological equipment, and a seismograph. Once the investigation of a site is complete, Dragonfly will conduct reconnaissance flights to help scientists locate the next target and determine a safe location to land. Each flight will last up to 30 minutes with a maximum speed of 10 meters per second, and cover up to 8 kilometers, allowing the probe to cover several hundred kilometers during its multi-year mission. Dragonfly will initially land in dunes north of the Huygens landing site, at the western edge of the dark region called Shangri-La. After a series of flights to explore this region, the copter will fly northwest to Selk, a geologically young impact crater, 90 kilometers in diameter. Data from Cassini shows that the terrain around this crater exhibits brightness differences that may indicate cryovolcanism caused by the impact. While Dragonfly will investigate the sand dunes and craters of Titan, it will not be able to explore another unique surface feature, the methane lakes and seas. Titan is the only world in the solar system, other than Earth, known to host stable bodies of liquid on its surface. Liquid methane is possible on the surface due to Titan's thick atmosphere and frigid temperatures. Using radar, Cassini mapped the complex system of connected lakes and seas in Titan's northern hemisphere. The largest, Kraken Mare, is bigger than the Caspian Sea on Earth, and is at least 35 meters deep. NASA is studying probes to explore beneath the surface of this cryogenic sea. A nuclear-powered sub would travel to its depths and then surface to send data to an orbiter for relay back to Earth. But there are many technical challenges to solve before such a mission can become a reality. Meanwhile, scientists are busy flight testing Dragonfly's control system and completing wind tunnel tests of its rotors to prepare for construction of the spacecraft. But until Dragonfly is flying in the skies of Titan in 2034, the James Webb Space Telescope will provide some of our best views of this distant and mysterious world.